Hi, greetings for the day. Myself aput17119634 from Cloud Computing. My research topic is ensuring an efficient data storage using fully mature homomorphic encryption in cloud computing. I would like to explain about the problem overview, the literature review, and the implementation and tools that I intend to use throughout the research. The amount of data is growing rapidly. As the data grows, the users have to store this huge amount of data somewhere, and securing this data is also very essential, especially for classified data like government files and research papers, etc. So here cloud provides a platform to store this type of data, but there is always the threat of a third party eavesdropping of our data. Therefore, we need to encrypt the data by using much complex algorithms. And in this part, I will be briefing some of the previous works related to my proposal. The first one is Gentry's fully homomorphic encryption scheme by Gentry. In this, the key generation method for the underlying somewhat homomorphic encryption, which does not require full polynomial version, is explained. In this, the public key size ranges in size from 70 megabytes for the small settings to 2.3 gigabytes for the large settings. And the second one is homomorphic encryption for security of the cloud data by Mr. Manish Empote, Dr. C. Dothap, and by Mr. Deepak M. Sharma. Here, the data is stored in DynamoDB of Amazon Web Service in public cloud. It provides confidentiality to the data because in no stage data is exposed in a plain text. And the third one is using fully homomorphic encryption to secure cloud computing. Here the homomorphic encryption allows to perform computation on encrypted data without decrypting this data. This will provide much better security. And now I will be explaining about my research method, which is the fully mature homomorphic algorithm. Here, as you can see, the system model is by using FMHE, which is the fully mature homomorphic encryption. We assume that the storage service and the computer service and the processing service will be provided by the cloud provider, and these are the entities that the operating principles involved in our model. The first one is data owner. Data owner is usually the enterprise or organization who possesses the raw data. It receives the public key from the processing center and encrypts the private data. Then it sends the encrypted data to the cloud database. It has only encrypted functionality. And the second one is storage. Storage is actually the cloud database that is responsible for storing this encrypted data. And the third one is processing center. The processing center produces the public key and secret key. It has the functionality of key generation, and additionally it analyzes the user's request and tells computation center which data requires certain computation. And the fourth one is the computation center. It is responsible for performing the operation requested by the data user. It receives ciphertext and formula and returns the final ciphertext results to the processing center. It has evaluated functionality. And the last one is the data user. The data user has intention to perform operation on encrypted data. It obtains the final results from processing center without accessing any intermediate result. It has the decrypt functionality. And here we will be explaining about the algorithm and encryption part. The fully mature homomorphic algorithm have three algorithms mainly, which are key generation, encryption, and decryption. But the key generation is the algorithm to generate the secret key, and the encryption is where we will be encrypting the data using the secret key generated in the first algorithm. It takes as the initial initial data that we'll be using to encrypt SP, and mode as part of the secret key, and T as the multiplication table, and C as the ciphertext. These all will be explained in the further steps. In the decryption, here it will use the the secret key to decrypt the original data. Here I will explain each section in detail. The first one is key generation. If the encryption is simple, it will be easy for a third party to access the user data. Therefore, here I will be generating security key using complex algorithm based on the prime modular, GCD, and complex mathematical computation. The encryption key is a secret and consists of a set of relatively prime module and two set of vectors. This is the demo of the model of algorithm, the planning to implement key generation. So as you can see in here, I have used prime moduli and GCD along with the mathematical computation for key generation. M will be the secret key generated here, and here this one is the demo algorithm for the encryption. The input parameters for this algorithm is p, and the generated key will be 264 bit in length. And the third one is the decryption demo algorithm for the proposal. This algorithm's input parameters are the ciphertext C. Here, to decrypt the original data, P should decrypt C by using the secret key. Here I will be explaining about the tools and the testing part. The MATLAB is the tool one of the tool that I'm using. MATLAB is a proprietary programming language developed by MathWorks. MATLAB allows matrix manipulation, plotting of functions and data, implementations of algorithm. The fully mature homomorphic encryption prototype will be developed in MATLAB. I will be using MATLAB to do the computation to create and run the algorithm to get the secret key. As for the testing, we will have to perform testing by using multiple data tests simultaneously to test the quality of the algorithm. Now we will be using the CryptoDB dataset to perform the testing under various conditions for the demo. MATLAB will be used to perform these computations. Thank you.